Hey, it's Emily, your favorite PodRocket producer. Did you know that LogRocket has a TikTok now? You can catch up on all the interview clips from this show, watch UX tutorials, and get more great content from LogRocket. You can check out the LogRocket TikTok today at log.rocket. See you on TikTok.
Hello and welcome to PodRocket, a web development podcast brought to you by LogRocket. LogRocket provides AI-first session replay and analytics which surface the UX and technical issues impacting user experiences. Start understanding where your users are struggling by trying it free at logrocket.com. I'm Noel, and today I'm joined by Florian Rappl, Solutions Architect at smapiot, GmbH, here to talk about his Git Nation talk, 8 Things You Did Not Know About Micro-Frontends. Welcome to the show. How's it going?
Hi, I'm fine.
Good. Let's jump right in. Can you tell me a little bit about what micro frontends are? I feel like this is one of those topics like people hear about, but not everyone has a super good grasp.
Yeah, there are a lot of definitions out there. And of course, the definition that is officially settled on is that a microfrontend represents essentially a business subdomain that's now modeled and contains all the components that are relevant for this business subdomain. So let's say in layman's terms, it's a collection of components that should make sense when used together, but it's not a full application, right? It's just a smaller part. You can think of them as fragments of a full UI, but again, consistently evolved or attached to a business domain.
What are the common misconceptions that you see? Is there a reason that you targeted these 8 things people don't know?
Yeah, there have been a lot of misconceptions in the past. And in this talk, I didn't want to, let's say, focus on the misconceptions in particular, but rather on, let's say, technical things that microfrontends allow you to do that traditional monolithic applications don't allow you to do. From the misconceptional point of view, there are some, of course, as well. And I would say the biggest one potentially is even that you need a lot of people and large teams to use microfrontends. Surely this might be one of the reasons, but even if you have a smaller team, microfrontends might make sense under certain circumstances, right? So it's all about the use case and where you want to see how you are set up organizationally, but also what's your technical problem and challenge. And here again, this is where the talk really anchored on and what you can even do with it, just to show people there are more things that you can tackle with microfrontends than just breaking up big teams and organizations.
Maybe just to give us a bit of a foundation for our conversation here, can you give a quick overview of the architectural pattern, like from a technical standpoint, of how a front end that has micro front end pieces, how that would typically manifest, how it exists and how it's deployed?
With microfrontends is all about the runtime composition, because what we are talking about, and that's, I think, the fundamental difference to monolith, is that the development can happen in a distributed way. So the easiest way to think about it is instead of having also monolithic code base, we have everything in one repository, you now can have multiple repositories. For one reason or another, many microfrontend architectures or code bases are still using a monorepo, but don't confuse that they use a monorepo with the need that you have everything in a single repository. So generally, microfrontend architecture can be done in multiple repositories because you don't need now to have, let's say, one build step where everything comes together. What you actually want to achieve with them is that teams are really independent, which means they run their own pipelines, for instance, to publish code. And then this code comes together at runtime. Now, where this runtime is, on the server, right, on directly on the client, so in the browser, this is now depending, of course, on the choices you make for your application. Historically, microfrontends have been a great choice for single-page applications, so it might be in the browser. But as we see that the server-side rendering becomes more and more, let's say, in trend and necessary even again for performance reasons and others, microfrontends are also done on the server too. And the first implementations there have even been on the server. So it's not that microfrontends always have been as a single page application. It just made sense that the primary target of composition is in the client. But again, it shifts now. And in general, you can have multiple choices here as well. But the distribution of code and the composition that happens at runtime instead of at build time, these are two of the core technical properties that you see with microfrontends.
Yeah. Are there any particular challenges as things are pushed back towards the server, or I guess as we have front-end libraries that are advocating for developers to start doing server-side rendering a little bit more via explicit components or implicit components, or however that ends up manifesting? Are there any challenges to using some of these newer tools with a micro front-end architecture?
Yeah, certainly. When you, let's say, only focus, for instance, on the client as an example, there are still some challenges, of course, but the problem becomes simple in the way that all you need to do is load fragments of code, maybe, of course, take care of some of the problems that might arise, like how do you share dependencies and how do you isolate certain things, like, for instance, CSS styling. Now, with the server, of course, similar questions first come up, but there are now multiple layers that you could consider. For instance, one thing on the server that might be interesting is instead of composing everything in one process where you say, okay, now I got the information like I do in the browser and I just have a single rendering step and then spit out HTML. What if you have instead different servers and they already return HTML and you want now to combine this HTML? Sounds easy at first, but then there are, of course, certain edge cases that arrive. And the first one is, what are we doing now with resources that are potentially inside the HTML, right? Because right now, these might be relative links that only are valid within the one server. But if you just return it back to the client, these URLs, they don't make sense anymore. So you need to find those and replace those as well. And then the code that you just compose together, they might have forms or something like that. So they also would need to return, and the form submission should now go back to the original server. And that brings us to the next challenge. What are we doing with the session? Is the session valid on the server that composes everything together? And how do you transport it with all the contextual information back to the server where you got the respective fragment from? A lot of questions arise. I would say the simplification of all that is just render on a single server and do pretty much the same that you do in the browser. But even here, we are not done yet, right? Because these days, and this is where now these frameworks come in, they want to tackle a lot more. They also want to solve essentially from the server side, client side interactivity, and some of the frameworks that do it differently. But if they use a hydration model, let's say, where still there's some JavaScript running on the client, how do you now compose that JavaScript? You have now essentially two compositional targets, right? One on the server that already generates HTML, returns it to the client, and then the same in the client. So suddenly your one problem that already was challenging enough became even more challenging. This is also the reason why it took a while now for these like island architectures, like these more modern architectures, to have a little bit of, it's not that they haven't been attractive, it's just that they have been much more complicated than the ones that we already tried to solve. And these are some of the things that, are at the moment going on all in the microfrontend space. And I think it's quite interesting to be there because technically it's a lot of challenging problems to face, but quite rewarding in the end, I would say.
Yeah. Do you think that like the frameworks in general have underserved this use case at all? Do you think that these like meta frameworks have made it more challenging to set up a micro front architecture? Or do you think like there are tools that make it sufficiently viable for devs?
Yeah, in general, I think you're right when you're saying they have not respected this enough, in my opinion. So just to take two examples to see a little bit of a contrast. On the one hand, we have Next.js, a really big meta framework, right? Just released a new version. They're always having great releases, but of course, it's known to be, let's say, not the most lightweight one. And it focuses really a lot on having everything in a monolithic code base. And here, especially with the build process, which is quite shielded and very hard to extend, it becomes quite challenging. Also, the server is quite picky what they came up with. While you can still do some hydration, of course, on the client, and introduce microfrontends there. When you want to have a real, let's call it full stack microfrontend, where you, of course, maybe let's say have something like a React server component, not already within your build process, but coming now from a mic, and then having this thing still hydrated, it becomes, I don't want to call it a nightmare, but from a technical point of view, it is very close to that. On the other hand, we have something like Quick, for instance, which from the beginning already saw that there might be a use case for something like microfrontends. And so they already embedded it somewhat in the documentation. The Downside is that, of course, their perspective was very quick focused, which, of course, is their right. So they are saying, yeah, we do micro frontends, but you have certainly the best experience, or if you just use also quick for your micro frontends that you develop there. And then it is a somewhat acceptable experience, meaning you still need to code a bit, but it's not that doors are blocked like in Next.js, for instance. So here we see something that is a lot more open. But yeah, I would say it's still a step to go before we reach a level where you can just use it and you don't have to write any boilerplate or gluing code that brings the microphones into your application.
I feel like we're talking too much about like the challenging and why this can be hard of these 8 things people don't know. What do you think is the most compelling? What should be attractive to people about micro frontends?
I mean, they also have a little bit different use cases, but if you would, let's say, point a gun at me and say one of the things and this is it, then I would say the conditional rollout with, for instance, feature flags. Because once you have that, all of the other things naturally flow in there, rollbacks and just-in-time deployments, everything where you say, oh, okay, didn't know that microphones can do that. Once you see that you can do feature flags, the rest just follows. Just to go a little bit into that one feature, it's that what you usually can do with microphones is, let's say, 2 big ways. And one way is what I would call always the strongly coupled way. This is you already know certain components existing in certain microfrontends, and so you just, in quotes, import those components, right? There's still usually a helper in between. Let's say module federation is, of course, one of the examples that usually comes up. But you load it with the help now of module federation, and there you go. It feels a little bit like a monolith again, just that you have still this one uncertainty factor because it still happens at runtime, so anything can happen, right? Now, the other way is that you make loose coupling, and how it works is that instead of importing now a component, you just say, here, got a slot where someone else can render in. Now, you need an orchestrator. It's a tool like module federation, you could say, but it operates on a different level. So it's not concerned with how microphones are loaded and dependencies are shared, but rather what information are the microphones bringing to the table. Now, once such an orchestrator, you can think of it like Kubernetes for frontend, right? So who knows what microservices are there, and now the only thing it needs to do is allocate the necessary resources and let it run, right? So in this case, it's very similar. The orchestrator has the information, what components are there from what microfrontends. And now if there's a certain slot rendered from a component within a microfrontend, the orchestrator takes over and says, okay, let me see. So you open a slot for, I don't know, extra information on user. Let me see. We have, here someone registered some microphone, extra information on user. And it renders this component that comes from a completely different microphone, the user information microphone, I don't know, renders into this slot, right? So you reverse that. You can also think of it as like dependency injection just for components. And this way, right, you have the loose coupling. Now, what loose coupling allows you to do is you don't need suddenly that this one microphone requires another microphone because, right, if the other microphone isn't there that brings now this user information, the slot just stays empty. It's like a web component that was never defined, if you want to refer it like that. And so this way, you can now really turn on and turn off microphones on demand, which allows you to, for instance, deliver something or don't deliver it, the so-called microphone discovery service. Having all those machinery in place, the microphone discovery service can be connected to a feature flag service, and the feature flag service can now determine what microphones to serve for what users and what not. So there's example that I just brought up is the user information service. The discovery service could say, hey, is this allowed? Feature flag service could say, no, not in this region. Or no, this is a beta user. We don't ship this to a beta user or whatever. Could be multiple going on. But suddenly you have a UI that composes quite naturally and dynamically. And this can be really powerful, especially when you think about having alignment between what you ship in your front end and what rules you have in your backend already, authorization rules that then lead to the users allowed to access that resource or not. Suddenly everything is always aligned and consistent, which in my opinion is always a big win, right?
To me, it almost seems like it's solving a similar problem to a lot of what this work that's happening, that's pushing, these frameworks are pushing everything back up to the server. And they're like, oh, in certain cases, we don't even need to render this component. So let's not go through all the trouble of sending this down. Do you feel like these are like they're solving similar issues, or do you think that is some unique attribute to using a micro front-end architecture that is like an extra benefit on top of just trying to push all the rendering back up to the server with a front-end framework?
Yeah, I think there's definitely an overlap here, right? I wouldn't say that they are, let's say, exclusive, right? As explained on the challenging part on server-side rendering, there is still a use case for microfrontends on the server, and they are the there are, of course, multiple advantages, but the most advantages you will get also with respect to performance, right? Because now instead of bringing all the microphones again to the client, which, yeah, they should all have lazy loaded component, but still you bring a lot of information to a client, which for a particular screen might not be needed, right? So you have everything central in the server. That's always great. So that being said, sure, there's an overlap on the technical side, but then again, on the, let's say, especially organizational perspective, right, these traditional, the meta frameworks are doing can't, of course, compete because they always still need the monolithic code base. And now that you have the ability to give a certain team now this way of just developing their own set of, let's call it modules or microfrontends in general, right, is quite, yeah, in my opinion, quite empowering, especially now. And that's again where the server comes in. It doesn't need to be a server-side rendering. It can also be, right, that they develop two things still in their microfrontend, which one is like a microservice, could be seen as, would even call it a nano service, like a function as a service, right? Think of an AWS Lambda or an Azure function, doesn't matter. And also, of course, the microphone, because suddenly you have real full stack teams, right? They ship something where they also provide the backend side for it. Of course, that's not proxied through, I don't know, a gateway or something like that. But they're now in charge of the whole package, so to speak. And that's quite compelling in my opinion, because now there's no more, oh, you can't ship that because the backend isn't ready. You're also doing the backend. So you are always sure that your thing is shippable as one unit, front and backend together. And so, yeah, I think it's the next step in the evolution of microphones. We will see more and more solutions that really advocate this full stack pattern. It is possible right now, but I think at the moment it's too much focus on just one of the two parts, but the real power comes when you have both parts, right, in the hands of one team or one person, people in charge, let's say, for this one domain, as I call it initially, this one business subdomain.
Yeah. Can we talk a little bit more about this kind of like code isolation in general, how that impacts like CI/CD and rollouts and some of the benefits there, and maybe also some of the challenges there? But let's start with the positives. People have a general idea of why this is nice, like for typical backend code development. But as you said, like a lot of people still end up using a mono repo for doing that. Are there benefits beyond just like isolated deployments that you typically see in the micro front end context?
The isolated deployments certainly make the most sense. There might be also, let's say, organizational reasons for having your own repository, right? Let's say you're really a big team, but there are also, let's call them external teams, so from some third-party vendor so service providers that you let in, do some of the work. Now you can really give them their own fraction, and you never need to worry that they did something in the code base they shouldn't, you didn't set up a proper guard for it, etc., right? So these things, maybe they are not even allowed legally to look at the code of the main repository, and so you can just really easily set that in. The other, of course, is can still in a monorepo, of course, have all the checks that you say, okay, all these modules, they haven't changed, so you don't bring them online, so there's no new version, and the CI/CD time also can be in a monorepo quite small, but still multiple repositories allow you to more free in your tooling setup. So example with the third-party vendor from beforehand, they don't even need to host their source code at the same location, right? So you could use, I don't know, GitLab, and this team uses Azure DevOps or something like this, or another team uses GitHub. So as long as they can all reach, for instance, a microphone discovery service that then takes the artifact that's deployed, everything is fine. I would say this is indeed the best way to have it. Regarding real code isolation at runtime, then, I think things get dicey because in Node.js, for instance, we can do proper code isolation with some tricks, of course. I wouldn't even call them tricks, but there are some things brought in already. So when you dynamically evaluate modules that came in, you can always put them in a new context, and you can even define what's available in that context. So quite nice. In the browser, such a thing doesn't exist. So if you want to have real isolation, you will need to use an iframe, which is the most classic microfrontend solution. So that has been there since whenever someone classically in the 2000s used advertisement. Well, that was an iframe, right? Now it's more hidden, right? You use, I don't know, a third-party provider that gives you a chatbot that usually is just a script that you introduce in your site, but in the end, it also will open an iframe, because this way it just makes sure not only that styling is isolated, you can do that in Shadow DOM as well, but especially that the scripts don't collide, whatever you brought in. And so they will always open an iframe, even though that comes with some challenges. So just a word of warning to anyone trying is saying, then we just do iframes. Iframes aren't, if you have an in-house microphone solution, they are not so easy for performance reasons, but also on top of them for other reasons like layouting is really difficult with iframes. Yeah. So anyway, there is no real code isolation in the browser for JavaScripts for something where you share just the same document object model. And I don't know, everyone brings some React components, for instance, to the table, and you want to have one React render tree here. There's no code isolation, obviously, without any trouble at least. So iframe, there's also evaluation of JavaScript within WebAssembly. There are other tricks, but all these tricks, they are really don't go there. They are not really performing, and they're really hard to tame.
Yeah, I think while we're on this topic of the trickiness of code isolation and this like the membrane between separate micro front-end components, are there any particular challenges that you see teams facing or that you hear about where there is some kind of coupling between front-end components and teams are trying to figure out how to draw those lines, where things should live? Even something like dependencies, say there are two components of the micro front-end framework and they do need to go out together. There is some piece where there's communication back and forth to some degree. Is this a challenge that you commonly encounter?
So what you just said about how to cut it, that's like where it all starts, right? Because there's no right or wrong here. But consistency is key. But finding it, let's say, when you just lay it out and then have initially the right idea is challenging. But then again, communication is really difficult. Sure, the main communication patterns like events or we have a state container or something like this, that all works. But then again, what I just said initially about this orchestrator, you just have a slot and the orchestrator makes sure that something renders in the slot. This is also a way what potentially tackles 80 to 90% of the cases. The most challenge I see otherwise technically is really sharing of dependency in the front. And of course, someone might now come from the backend and say share nothing, but we are talking here not about a big server that we can scale up. We are talking about maybe even a mobile phone where the web application is then consumed. And so you don't have infinite resources and you need to make sure that your things are really, let's say, just working fine. Plus, sometimes it's necessary to share things because you can't just duplicate them. Two examples. First is React-based. You can't have the same React render tree and have different versions of React bundled. That might initially seem to work, but once you have, for instance, a hook in there, you will get exceptions because there's a singleton in there, you don't see it, right? But it's attached to the rendering tree that you have. And so suddenly it will say, oh, but my dispatcher is still set to null. What are you doing? And that doesn't work, unfortunately. The other is that there are dependencies that might do something where they either collide them because they still have something like the singleton of React, right? Maybe even a property on the window object or something, or they do some checks. PDF.js is one example here. They have a web worker with the package included, and it communicates with it, and it makes sure that there's only one instance for, I don't know, I think it's just really a protection mechanism that they have in there. It's not really required, but it still now makes sure for you that you can't have two different versions, for instance, bundled. It then throws in exceptions and say, wait a minute, I've already seen version, I don't know, 3.2.1, and now you give it to me 3.3.1. That can't be right, and it will just error out. So you need to share PDF shares as well. There are real reasons why you need dependency sharing, and this then opens a whole can of worms, right? And so this is where teams usually struggle a lot because it's obviously not directly visible. That here will be a challenge.
Yeah, cool. Let's end on a little bit of a high note before we get into some rapid fire questions. What are some performance improvements that you see in micro front ends comparing to more typical architectures?
On the one hand, of course, give you already, let's say, a developer convenience improvement in that sense that suddenly instead of having a whole big code base on your machine running, you have a really small code base running. So that makes start of debugging, the build processes, of course, all that a lot smaller. The other thing is, of course, that these micro frontends, they usually come with a set of rules. You can't just have everything bundled, shipped in 2 megabytes of a microphone, and that's it. All the components that are in there are out of the box lazily loaded. And so they are also already having you have the microfront as a collection, but within you have now all these smaller bundles. So it gives you essentially React lazy loading instead of you needing to do that and do a lazy import in a React lazy, for instance, out of the box. That's quite nice because that ensures really that all the things that you don't need, they are only loaded on demand. And I think that's already a big win. Otherwise, of course, pretty much like a monolith, but you get these things without needing to do something. And I think this is quite nice. Plus, for the end user, you don't have this massive change all the time. For instance, if you have a monolithic application, even if you use now, let's say, lazy loading, once your build process runs through, you get usually all the hashes changed. And that's just because there's a cascade, right? So if one hash changes, the import of that changes. So that hash changed as well. And you get that up to the root. So every hash changed, even though there might be no change, right? Now with a microfront architecture, if you just deploy this one microfront, then the URL of it changed, maybe because there's now this new version in the URL. However, all the other microphones remain the same. So if they are once loaded, there's no need to change them. And that's one of the reasons why you can cache always these microphones indefinitely in the browser if you do a single page application. So a first load might still take longer. I don't know, can also be optimized. But then hot loads are usually much faster than the monolithic.
Yeah, I hadn't really thought about that kind of implicit caching advantage there, where it's like, you have resources that haven't changed. That's cool. Before we wrap things up, let's get into our quick round here. Just some rapid fire questions. What's the biggest misconception about microfrontends?
Yeah, I would say that you need a big organization to roll out microfrontends, even though, of course, in most of the cases, it makes the most sense. There are technical reasons why you might want to look into microphones, even if you just have one team or a few developers.
Gotcha. What's one mistake teams should avoid when starting to explore microfrontends?
Try to do everything at once. Start with one of the simpler solutions that give you, for instance, a full framework. Because if you start with lower level tools, for instance, just Modi Federation, you will end up writing your own framework. And that's something you shouldn't look into in the beginning. Look at something simpler, see if that already, let's say, fulfills your use case, and then go with that. And do the same also with your microphones. Maybe don't start with, we lay out 50 microphones, just a few, and then you can always extract into more. But don't get into too many too early, right? Always make one step after the other.
Yeah, are there a couple specific tools you'd recommend devs check out if they are looking to switch to an architecture like this?
Yeah, I would definitely tell people to have a look at either Pyrel, which is a framework for microfrontends and gives you everything out of the box, starting, of course, with scaffolding of new microfrontends, build processes, etc., browser extensions, VS Code extensions, everything. Or on the other hand, if you were looking to extend your portfolio where you already have Modi Federation and maybe other things, then Picard.js might be a good look. That's just a plain orchestrator, but it works together with all the formats that are out there. Modi Federation, Native Federation, pilots, you name it. And of course, a full component model, single spar, your own component model, React components, whatever, you can throw it in there. It will work with it. And it allows you already to go into loose coupling. And this is, I think, a great benefit.
Nice. Okay. Last question. What's your favorite part of developing in a micro front-end framework?
That I don't need to have the full cognitive load of a whole application, right? I can just write smaller parts, and I'm sure that when I ship them, they just work, and then I don't look at them, hopefully ever again, but maybe something comes up. Then I'm also glad I made a microphone out of it, because then redeploying that, etc., is just much simpler than if I need to do something with the whole code base. It's just, for me, cognitively much simpler to reason about.
Cool. Okay, well, be sure to have links to those tools we just mentioned in the show notes so people can find them later. Anything else you want to leave listeners with, Florian?
Don't feel intimidated by a lot of the articles on microfrontends. Try to figure out what works for you best, right? If modular architectures are always good and then you can play around, it doesn't need to be runtime composition. Maybe start with a monorepo first, and then you can always go into microfrontends when you really feel the need for it, but really just have something that solves your problem, not solve somebody else's problem. Really just stick to what you need.
Perfect. Thank you for coming online and going through all this with me. I know this is one of those that's a little bit abstract, so it's hard to always cover in an audio format, but I think we did our best there. But anyway, thank you again. Take it easy.
Thanks.